All right, you've got the packet. Let's start in on 4B. The warm-up is to use this unit circle to fill in this table, and we've actually already filled in this table in 4A, but we filled it out with more points, and I'm hoping that we can do that here to get a clearer picture. It's going to help us for later. So please write in these extra points to find. Oh, there's not one there. And again here. And I went ahead and filled them in because we already did them. And I'm going to do the rest of that here, as in graph them. Okay, so there we have our graphs. And now we're going to find the reciprocal for all the points that we had before. That is why we needed the extra points. Okay, it looks like root 2 over 2 is a bit of a repetition, so root 2 over 2, what is the reciprocal of that? So we flip it, we get 2 over root 2, and we need to rationalize. We end up getting 2 root 2 over 2, and that is root 2. So the reciprocal of root 2 over 2 is root 2. Good to know. Let's fill in these tables. Okay, so we've filled out the tables. Just as a reminder, anytime you, so the reciprocal of 0, so 0 over anything, if we were to change it to 1 over 0, that would be undefined. So the reciprocal of 0 is undefined. That means our reciprocal functions are going to have several places where they're undefined, and that those values will be represented as vertical asymptotes. If you remember, we had asymptotes in our when we graphed rational functions. Okay, so let's graph these points on our same graph with the sine function. Okay, we're going to graph its reciprocal with it. One other side note is that when we graph, root 2 is kind of hard for some people to graph. That is approximately 1.4, so that's where you will graph those points. Let's do that now. Okay, now I'm putting in the asymptotes. Wherever it says undefined, you should have a vertical asymptote. And what's actually happening is it's like you have a line here, and this point is as far away from this line as this point is, kind of like a reflection. You're reflecting up those 2 points. So what's going to happen with the reciprocal function, when we connect those, it's going to be like you see this mound, and then it's going to be reflected facing upwards, so it's going to go this way. Oh, that's real pretty. And vertical asymptotes are like fences. You can keep approaching them, but you're not going to cross them. And then connect those points. Again, it's like these little parabolas, these little U shapes. And we just kind of know that they're going to go back up in that sense, so I put arrows there. To graph cosecant, you just graph the corresponding sine function, okay, like we did up here. Then you'll sketch the asymptotes of cosecant at the x-intercepts of sine. So anytime that sine gave us a value of 0, that was where cosecant gave us an undefined. And that's where our asymptotes were. And then you'll sketch the u's of cosecant at the maximum and minimum values of sine. So when you see a maximum value of sine, such as this one, you will have an upward facing u for cosecant. When you see a minimum, you will have a downward facing u. And same with cosine. You'll graph the corresponding cosine function for every secant that you're given. You'll sketch the asymptotes at the x-intercepts and sketch the u's at the max and min values of cosine. So let's do some. All of these will be in My Locker, the My Locker tab of School Loop, and will also be sent via Remind. So please join that. Check your School Loop email if you haven't. Okay, our last one. We're going to graph the corresponding, this is cosecant, so sine graph, 2 sine theta plus 5 pi 6 minus 1. Okay, absolute value A is 2, B is 1, C is, again, remember to change the sign, negative 5 pi over 6, and we do have a vertical shift, which is negative 1. Ooh, we got lots of crazy stuff going on. Okay, phase shift is C over B, so negative 5 pi over 6 over 1, which is just negative 5 pi over 6. Amplitude is 2, period is 2 pi over 1, which is 2 pi. Okay, phase shift is P1. Remember, P1 represents the x value of the point, not the y value. That you know based off of memorizing the visual, how it appears. Okay. P5 is P1 plus the period, which is 2 pi, but I would like to put that in terms of 6, so that's 12 pi over 6, so 7 pi over 6. Okay, let's find P3 by taking the average of P1 and P5. Okay, you end up getting 2 pi over 6 over 2, which is just going to be 2 pi over 12, which is pi over 6. Okay, so we should have P1 is negative 5 pi 6, then we have negative 2 pi 6, which is negative pi thirds, then we have P3 is pi 6, P4 is 2 pi thirds, which is 4 pi 6. I like to have everything in the same denominator, so I'm going to use sixths. And P5, which is 7 pi over 6. Negative 5 pi 6 to 7 pi over 6, so a little bit more in the positive. Okay, so our amplitude is 2, but remember that we also have a change in midline. Okay, so this right here, let me use this right here is at -1, which means everything's centering around -1. It's going to go 2 units above -1, 2 units below -1. And that's just the sine graph. We also need to take into account that we're graphing cosecant after we finish graphing sine, which is above and below. So I'm going to give us a -1 as our midline. 1, 2, 3. Okay, so our midline is at -1. I usually like to use a highlighter, but my highlighter it will make the midline super wide, so I'm just going to use the blue. This is our midline. And then we're cutting up the x-axis in sixths. -5 pi 6 is almost a full negative pi, so I'm going to write this as -6 pi 6, which is negative pi, and I'm going to cut this up into 6 sections. How do I do that? First, for 6, you cut it in half, and then if you cut 6 in half, you have 3 and 3, so you need to do 2 tick marks in the first section, and 2 tick marks in the second section. Okay, we're going to do that as well over here. So this is going to be 6 pi over 6. Usually I would label it below, but the midline is kind of in my way, so cut in half, and then thirds, and one more, of course, to recognize the P5. Okay, so -5 pi 6. This is sine, so we start at the midline. At -5 pi 6, we start at the midline. At -2 pi 6, we go up to the positive amplitude, which is 2. So 2 above -1 is +1. Then at pi 6, we are back at the midline. Remember, the midline is not the x-axis, which is really hard to remind yourself of. Okay, down, so then we have 4 pi 6, 1, 2, 3, 4 pi 6. You're going to go down 2 below the midline, so to -3. And at 7 pi 6, you're back at the midline. Whew, you did it, you survived. Okay, now we should have asymptotes where you would have intercepts. So remember, intercepts of the midline. So we're going to put those asymptotes in, intercepts of the midline. And here's a maximum of sine, so I'm going to draw an upward U. Here's a minimum of sine. I'm going to draw a downward U. The cycle of the reciprocal functions is the same as the cycle of sine and cosine, 2 pi over b. So that means that 2 u's have to complete, you have to have 2 u's to complete a full cycle, a full period. Here we have like a half u, a half u, and then a full u. So that's satisfactory to me. That's fine. All right, so go ahead and do practice 4B on your own. Again, it will be sent over School Loop, put into my locker, and sent via Remind. So enjoy learning in your pajamas, y'all.